Chain rule for power function. Well, power function is a very special function, and see how we apply chain rule to find derivative of power function. So we are given here y equals to x squared minus x plus 1 whole to the power of 5, and we need to find dy dx at x equals to 0. So we'll see how to evaluate the derivative and how to see it as a chain function. Now, what we can do is we can substitute all this as another function. Let's say u equals to x squared minus x plus 1. Do you see that? In that case, if I substitute u equals to x squared minus x plus 1, my y value will be equals to the u to the power of 5. Now, it becomes composite function. Do you see that? So y is a function of u and u is a function of x. That is how it is a composite function. Now what we can do is we can find derivative of u with respect to x. So du dx is equals to 2x minus 1, and here we can find derivative of y with respect to u, which is 5u to the power of 4. And now, using the rules of chain rules, we can get dy dx. So we get dy dx equals to dy du times du dx. And that gives us dy du is 5 u to the power of 4, right? So instead of u to the power, let's write u to the power 4 at present. So 5 u to the power of 4, and then du dx is 2x minus 1 times 2x minus 1. So we get our derivative dy dx. Now this is like in combination of u and x. But really, we need to find dy dx at x equals to 0. Now, if x is 0, what is u? Let's try to figure out that. So when x equals to 0, we have u equals to x squared minus x plus 1. So if I substitute 0, then I get 0 minus 0 plus 1. That means u is 1, right? So we can find derivative dy dx in terms of when x is 0 without really expanding this or writing u in terms of x. So this is kind of important to understand since it saves time. So we will find dy dx when x equals to 0, and we notice that when x equals to 0, u is 1. So we write u equals to 1. And our derivative is 5 u to the power of 4, so which is 1 to the power of 4, and we have 2 times x is 0, 0 minus 1. So what do we get? So we get 5, and 2 minus 1 is 1, so we get 5. So the answer is y, 5. So we get dy dx at x equals to 0 equals to 5. Do you see that? So that's how we can evaluate derivative at a point for a composite function, and here power function is being treated as a composite function. I hope that helps you to understand how we can differentiate complicated power functions. Thank you.